Hello. What are you doing all the way out here?
Hi. I'm supposed to be in economics, but sack it. Anyway, I have a nightmare of a test coming up and I am clueless, man. You wouldn't happen to know how to differentiate between distinct types of interest, would ya?
Oh, you're in luck. I happen to be an actuary.
I know an actuarial joke. An actuary walks into a bar.
Well, you have generally two types of interest, simple and compound. Simple interest is the case where investing X pounds at a fixed interest rate of I% gives you a return of X times 1 plus NI, where N is equal to the number of years.
Simple interest is actually quite, simple for to understand. It's the other types that are very difficult to take in.
Compound interest is considerably more difficult to comprehend. The concept of compound interest is that interest is generated per month or year on money you have invested. However, as your money gains interest, further interest is generated on the amount of money invested with the previous interest already added.
Wait a minute. So if I invest X pounds for 2 years, at I% interest rate, I get back 2 times X on 1 plus I?
No, not exactly.
Oh. Then how do I work it out?
Your return is X times 1 plus I all to the power of 2, as you are investing it for 2 years.
Oh, I probably missed that lecture. Anyway, the real problem I have been having is this thing called forceful interest. Or was it force of interest? Have you heard of it?
Yes, I have. Force of interest is essentially a type of compound interest. Let me ask you a question. Have you ever wondered when they pay the interest into your investment?
Nope.
Okay, normally interest is paid at the end of the time period, be it monthly or yearly. However, to understand the concept of force of interest, we consider that interest is paid continuously, i.e., your fund is accumulating interest constantly.
Then why is it called a force?
It's because we can now think of this fund as a continuous or constant force. Therefore, we can denote the force of interest at time t using the Greek symbol delta. The force of interest, or delta, is used in tandem with normal interest rates, present values, and the discount factor, as you can work out each of them using the others.
There's about 10 different formulae, isn't there?
No, just 3. Firstly, delta, i.e. the force of interest, is equal to the logarithm of 1 plus the interest rate.
Right, okay.
It is also equal to the minus logarithm of the present value, v.
Go on.
Lastly, delta equals the minus logarithm of 1 minus the discount factor.
So the force is strong.
Haha. Yes, it is. You have probably seen the table of formulae linking each of the variables I have mentioned. You should look at it. It shows the relationship the force of interest has with other actuarial concepts. So, if you ever come across a question with a continuous payment, remember to use the force.